Hello, everyone, and welcome to our series continuing with Blueprint Labs. And we are going to be doing our workshop today on attacking data governance and privacy with Databricks and Blueprint. For those of you who have not met me yet, my name is Ruthie Senanaika, and I work on the marketing team here at Blueprint. And Blueprint is a technology solutions company, and we do everything from strategy to execution. And we are excited to present a bunch of new workshops, webinars, and demos. We've been doing this for a couple of months now, and we're really excited because we've had quite a few people who've joined us throughout these sessions. So if you are joining us again, welcome back. And if this is your first time, we hope you enjoy this, and we'd love for you to join us in further workshop webinars and demos. So you can always follow us on LinkedIn to learn a little bit more about these events that we have coming up. And you can check out our website at bpcs.com/events to learn more as well. But without further ado, I will pass it along. We have Kevin, Tenny, and Shannon who will be taking over this webinar for now. So go ahead.
Thanks so much, Ruthie. Hello, everybody. Thanks for joining us today. Kevin Donahue at Blueprint. So today we're going to talk about Databricks and privacy, and we want this to be a practical-minded approach to talking about data governance and privacy. We're going to talk about some interesting features of Databricks, but we really want to put them in kind of real-world examples so that we're not just reading the manual to you. As Ruthie mentioned, I'm joined by Tenny Pan, who is a privacy technical program manager with extensive experience with privacy technology and product development. And Shannon Lauder is one of our solutions architects who helps us build our large-scale solutions for clients for their data engineering needs. So what's on the agenda for today? Obviously, data governance and privacy in the Blueprint and the Databricks environment. I want to start by just talking about some key questions related to doing privacy, just to set the stage. Databricks provides some really critical privacy and data governance tools, but we really want to make sure we consider them within the overall data engineering and business environment of our clients. And so these tools don't operate in a vacuum. So I just want to bring up a couple of points or a few points to keep in mind as we go through this presentation today. We're going to talk about data classification and tagging, some tools that Databricks provides for that, as well as some strategies for approaching that from a data engineering perspective. We're going to talk about some privacy enhancing technology and approaches to actually doing privacy. So we'll talk about some of the options for configuring some of these privacy and security options within Databricks. We'll talk about some of the pros and cons, some of the things we think Databricks users have to consider, because you can't just set something and forget it. We want to really present the full picture of understanding the implication of setting some of these features on and what that means for your data consumption, your product development pipelines. We'll talk a little bit about auditability and security and the Databricks compliance and security profile, which gives us some really critical tools to understand what has actually happened within our environment. It's one thing to say we're going to configure things. It's one thing to say how we're going to use our environments. We want to demonstrate how Databricks gives us the tools to actually understand what really happened. And as you can imagine, that's important for security. It's important for privacy. It's important for incident and breach response and management, all those fun things when you need to know what really happened. Next slide, please. Thanks. So before we dive into the actual features of Databricks, where my colleagues Tenny and Shannon will really dive into the details, I just wanted to put these 4 points before us, and I would just say these to me set the stage for when we're actually doing privacy within a business that's using data, that's using personal information. Where security is really concerned with the CIA, the confidentiality, the integrity, and the availability of the data. With privacy, it can get a little bit more, not complicated, but it's up a little bit level of abstraction, because we have to ask, not only what data do we have, but why did we collect it? What did we tell people we're doing with it? It's not just that it's secure, but when we want to use data within our organizations, modern privacy laws impose some obligations for companies to really know what they're using how they're using that data, what they're telling people they're doing with that data. And that can change over time. And so that you can imagine when you have a data store, it can be very attractive to teams. But we really want to have this overall data governance strategy for understanding are uses appropriate or inappropriate, what control should apply. That leads me to the next point. What are the actual rules that govern our use of data? These rules can be effectuated within the Databricks environment by setting some features up. But really, we don't just start with those features. We have to understand how do we know what rules apply, and then those rules get propagated via the infrastructure, in this case, Databricks. As I mentioned, how do we know what is actually happening in our systems? Again, from a privacy perspective, if you have a privacy notice, you need to give accurate information about what uses you are applying to that data. If that changes, do you have to go back and get consent or identify some legal basis? We see this in GDPR with like records of processing activities, where you want to be able to accurately understand not just what we think is happening, maybe in our documentation, but what is actually happening. And that's where that auditability comes into play in a lot of these data governance and compliance features. And then finally, how do we manage change? Over time, everything changes. And as we develop new products, as we identify new uses for data, these Databricks tools that we'll discuss today not only helps allow us to do that safely and respecting privacy, it also helps us understand, are we applying the right controls from a security perspective? Are we complying with our own policies? And as I mentioned, understanding what's actually happened in the system is kind of one of the key ways that we can demonstrate that actual compliance. Next slide, please. So this is just a very rough sketch of some of the highlights that we'd like to talk about today. We're not going to read the documentation to you. We're going to demonstrate these features. We're not going to try to touch every possible switch or lever or button that exists in Databricks that's relevant to privacy and data governance. We've identified 4 kind of main areas that we'd like to talk to today that we find clients often want to talk about. There's often a lot of questions about these areas. So we're going to discuss data classification and labeling. We're going to discuss, some market leaders that are partner, Databricks partners, some native Databricks functionality that allows you to do some really interesting work on data classification and labeling. You can't apply rules unless you know kind of what the data is, and if you can, label data and you classify and you label it, you understand how it's propagating through your system. We're going to talk about how to do that at scale. As I mentioned, privacy enhancing technology. We're going to discuss, some options again in the Databricks partner space, as well as the native Databricks functionalities for that. We're going to talk a little bit about actually doing privacy, data de-identification. We're going to mention differential privacy a little bit and talk about what some of the challenges and what some of the, in our view, reasonable use cases are. Sometimes it might be bringing too much firepower to the fight. Sometimes it might be exactly the tool that you need. So we want to talk about, how you would evaluate how to apply these different methods of de-identification and privacy methods. Security is always a popular topic. We're gonna dive into the CSP, as I mentioned. We're gonna talk about some of this native functionality within Databricks that will allow you to configure your data stores at scale and manage that change and talk about patterns and practices, so that when you set up your environment, you're kind of future-proofing it for future use cases. And then, as I mentioned, we'll talk about auditability. We'll talk about audit log schemas within Databricks, and then some strategies about how you can actually derive some value from those audit logs. How can you set up audit logging to identify valuable information? And then how can you grovel over those logs or analyze those logs to get some insights into what's actually happening, some things you care about. Again, that goes to that managing change. How do I know when apples change? How do I know when different products are using data? How do I know when inappropriate access or appropriate access is being granted or denied? Those kind of fun things we'll dive into. And at this point, I'm going to hand off to Tenny and Shannon to really dive into some of the Databricks functionalities. Thank you.
All right, so I'm kicking off with data classification and tagging. Anyone who's seen me present before knows one of my favorite topics is metadata, so data that describes other data. In the past, this is referred to databases, schemas, tables, views, etc., even down to the columns. But now we need to be able to describe multiple attributes for a given object. So this is where we start talking about tagging. So we want to be able to point at an individual column and say, this column's got PII, this other column is considered HIPAA, maybe this set of data here is PCI. Maybe some of it hits 2 or more. Maybe you've got PII that's also HIPAA. So tagging is the way that you can actually identify these different pieces of data that you've got in Databricks and then do something with it. So we've mentioned de-identification and some other features. But really, in order to do that, we have to know what to apply these different techniques to. So I know we promised that we were going to show you some Databricks functionality. Unfortunately, the Databricks tagging system is still private preview. We don't even have access to it yet at this point. Good news, it's supposed to go public preview with the next release, which is next Monday, I believe. So hopefully the next time you catch this or another one of our presentations, I'll actually get to show you Databricks native tagging. In the meantime, though, let's say you're in a situation where you absolutely need to be able to tag your data today to get started on your privacy practices. The Big ID is considered the market leader. And the reason for that is they are the only provider who can actually prove they're using machine learning and AI techniques to find and actually discover data that should be tagged. Everyone else may claim they're doing it, but a lot of times you can actually boil down their rules to regular expressions. It's great for maybe 80%, but it's not much more than a human going through and looking for it. You've got to know the patterns before you can find the patterns. So Big ID is definitely the market leader in this area. Databricks, even though they are releasing their tagging very soon, they've actually acquired another company, Okera, to extend their functionality. So there's a good chance that Databricks first-party solutions will contain that AI and ML assist like Big ID does. And when they bring that, it's going to be a game changer. But let's say you're in a situation like one of our clients recently where they can only use first-party solutions. So that ruled out Big ID. They also can't use private preview or public preview features. So what do you do in that situation? Well, you can still roll your own. And Tinny, if you can pop me over to the next slide. This is a really simple example of how you actually implement your own tag store. So this looks a lot like any metadata schema you've ever seen. We need a table to define our tags, their names, maybe some descriptions. We need a table that's going to help us define our values for those tags. So maybe you've got privacy as a tag with the options of PII, HIPAA, PCI, GDPR, etc. Then you need a way of tagging or actually tagging the object in question. So in this case, you see I've got a table called column tags. I've actually mirrored the internal Databricks information schema here. So instead of referring to my IDs, we actually lift the name and value and tag it onto catalog, schema, table name, column. Oh, column name is missing from my diagram. Sorry about that. But this is the table that would actually take those tags and tag values and associate them with a particular column. You could also have a table tag or a schema tag or even a catalog tag. You can tag at any level. And if you really want to get fancy, you could build a table that would let you tag sets of rows. You could have sets of primary keys from a table be tagged with these different tags and values. So once you have that store that lets you define your tags and assign tags to different points of data in your system, you need a way of controlling, well, how do we treat that data? So you've got to have a privacy function of some sort. Maybe you've decided that you've got one group of users who can only see a hash of a certain value. Well, the privacy function table lets you define that function is called hash, and this is the group that should use that hash anytime they're dealing with this tag. And once you've added this to your existing tag store, now you can start building in features all over Databricks. You can make these features appear in your pipelines. They can appear starting with ingestion. They can actually appear in views if you want them to. But this is the required metadata in order to know when to apply these different functions to these different objects. And once you can do that, we get to roll into what Tinny's going to show us next.
Okay. Thanks, Shannon. Yeah, so I just want to go through a quick example of like a sample data model and pipeline, just to kind of demonstrate, what we can do within Databricks to kind of build something that is privacy compliant. So just to start off, we've got like a streaming data set at our bronze layer. This is all of our raw data, and building upon what Shannon was talking about, if we've classified and tagged our data properly, we should be able to identify the tables and where we would have sensitive PII. So here, for example, we would have it in our customer bronze table, and that's kind of the example that we would be propagating throughout. So ideally, at the bronze level, once all of it is landed, no human should touch it. So as we're talking about access control and group memberships, the example that we're going to kind of show in Databricks, we'll have the data engineer role, the data analyst role, and data scientist role as to keep it simple. But for bronze, we would want to lock this down so that no human can touch it. And then as we move to silver, this is where all of our data has been cleaned. We've got data quality, any expectations, so that we have the reliable data for the data analyst group to then have access to, so they can do their work, do their analysis. And in this example, we've got a couple of gold tables. We've got materialized views, and this is kind of where the data scientist group will have access. So they have their aggregated data and also an example of the hashing and masking for PII, so that they are able to use the data for their needs. So create those ML models, create their algorithms while still protecting privacy. So customer gold secured is going to be the example that we're going to be looking at. Sorry, one sec. Move to Databricks really quickly. So I've got a notebook with a kind of a quick example of permissions and using Unity Catalog to kind of help control that. So I've got a couple of analysts, data engineers, and a data scientist group. So I've already kind of granted select permissions. And the great thing about Unity Catalog is all of this can be managed through code. So analysts, data engineers, but the one that we are concerned about is the gold layer view that has customer PII. For this example, it's just really simple. We're masking first name, which isn't the best example, but it's quite easy. So for this view, we're basically creating, similarly to Shannon saying, like a privacy function, where if you are part of the data scientist group, you're in this membership, you have a at runtime masking. So anytime you query this view, you aren't able to see first name. Let me see. I've already added myself to the data scientist group just as an example, and I've pre-ran this select statement, which is shows my group membership so that I am true part of this group. And for this query, I'm trying to see, select a couple of columns from this view. And as you can see, this first name is hashed. And the good thing about this, and there are other techniques that we can apply. So when you're talking about like your data model and your pipeline, this is just one example, because I'm for data scientists, it's likely they probably don't need first name as a feature in their model. You could potentially use pseudonymization or kind of build your architecture in a different way. But runtime masking is one of the techniques and patterns that we've been seeing, and one of the capabilities that we're seeing in Databricks. So with first name, and as part of my demo, I was going to show me dropping from this group, and then the fact that once I'm removed from this group, I'm now able to see the first name once again. So just a really quick example, and for this method, it has some benefits. So for example, if we're doing this runtime execution, we still are keeping that secret key, or the key in a secret, in a Databricks secret. So the key exists. So you're not exactly storing the data hashed. So it is available for when you need it. So for example, if you've done your models, you've had a data set for the data scientists. They have an output that maybe has a list of all the customers. They can bring back this hashed value and still be able to join on it. And maybe you need to, as a use case, pass it over back to the marketing team for their use. The key exists so that they can decrypt it and then connect it back to the PII and still be able to do their work. But all the downstream work, that all the modeling can still be done with privacy in mind. So, yep. Sorry, any questions on that or things I might have missed to touch upon? One second as I go back to the PowerPoint. Okay. So that kind of brings us to our next slide with privacy enhancing tech. So as we were kind of showing the example of, here's one way you can start to apply some techniques to enhance privacy within your pipelines, within your data estate. But the key theme that I think, Kevin, you kind of touched upon is kind of also maintaining that balance between business value and using your data and locking down and making sure that, there's privacy in mind. And, a couple of things to keep in mind. I think we've kind of touched on it, detaching the PII from attributes. So in the case that you've got data scientists that want to have access to a data set, maybe they don't need PII as a feature, and you could pseudonymize it, so hash those values as well. So there's a bunch of techniques there, and encrypted PII here at prediction time. So something also at runtime that we could use. And a little bit about differential privacy. So that's kind of one of the big topics. One of the things to consider, though, with differential privacy, because it essentially is a technique, a statistical technique of adding noise to your data set while maintaining relevancy. So here we see the Laplacian distribution. Shannon, you might want to speak a little bit more to this, but in theory, we're just adding noise enough so that the data set still maintains a similar distribution. So whenever you are adding noise, a lot of issues come up with when you think about the downstream users, like a data scientist who is basing their model off of this data, right? So it could affect the efficacy. So we're seeing kind of a shift, or our opinion being that differential privacy is a really good technique in terms of external use cases. So like sharing a data set externally, or something that needs to be published, and you want to be able to protect the privacy of those users or of those data set. That's useful. And then also in the cases that you are using it internally, which we've noticed that there might be some issues with scaling, but if you are using it internally, like for example, in a democratized data estate, the differential privacy, the noise is applied for a very specific use case. So it's important to keep in mind that, if there's not only access to that data set, and this is where data governance comes into play, is you need to make sure that anybody that does have access to the data set understands that that data set has been differentially privated for that use case. So if they want to use it for something else, then it could cause issues with their analysis. So Shannon, you have anything you want to add?
Yeah, so differential privacy, like Tenny mentioned, you've got to create it. You have to run your statistical model on your original data set. And for every use case you want to pull out of that same data set, you're going to have to recompute. So if you want to, let's do a simple example without privacy. I think it'll be a little easier. Let's say for each state, you want to run a total of the sales for your company. Well, you can actually take all the sales for the company, plot it on a chart, and it would look something like the red line for your sales. So if you wanted to make that private for some reason, or introduce noise, you're going to want to add so many negative values or so many lower values and so many higher values so that the new data set you're creating still has that same distribution. So that means you're making up fake aggregate numbers for your sales. But then if you want to come back and say, I want the min and max for that, well, we've got to go back to the original data set, rerun the min and max, and then apply this differential privacy to both of those columns. So you can see why this is very difficult to scale. You've got to know every use case up front for that data set, and no one ever knows this. It's impossible to know ahead of time. So
Shannon, I have a question about that.
Yeah.
When we talked about masking a slide or two ago, we talked about it at runtime. When we're talking about differential privacy, is this something that we can apply at runtime, or would that be too resource intensive, so we'd actually need to create tables?
Yeah. If you pulled this off at runtime, I would be very impressed, because the amount of modeling you have to do. This is generally something where you're going to pre-compute and you'll store it to a set of files, maybe even using Databricks Delta Share. So you'd want to introduce the noise as you're writing those files, and then you can just point your consumers to those files and say, these have been, these are noisy files, but you're allowed to use them for this purpose, and they can pick them right up. Yeah. Great question. Actually, before we move on, I would like to dive into quickly. Tinny did mention there are multiple approaches. Hashing, encrypting, simply pulling off your identifying columns and only publishing the attributes that you'd use for a model. When do you want to use each? Honestly, they're in the order that I try them personally when I'm architecting a solution. First pass, if you can simply detach the questionable information and still maintain the usefulness, that should be your first pass. You can do that at runtime. You can pre-compute it. It actually is the lowest cost privacy enhancing tech you can run. Second to that would probably be a hash or some kind of one-way transform. This is in those cases where there is some intrinsic value to that PII. Maybe, actually think medical. Age, race, while they are identifiable, they're also useful diagnostics for coming up with, looking for certain diseases. So in those cases, you could simply hash. You could add a salt and hash male and female. It's going to be pretty easy to figure out which is which when you start noticing, hey, these are the codes that are pregnant. Well, I can make a guess there, but age would be a little more difficult. You could always combine the columns, hash them together, so it's the combination of age and sex. While the distribution would be the same, you could extract the same meaning from that data without knowing what the values actually mean. So hash one-way transforms are great for that. Encrypted at runtime is great if you can afford the extra CPU that it's going to take to encrypt and decrypt on the fly. If you, at some point in the consumption of this data, you need to be able to get back to those plain text values, encryption is the way to go. The compute cost simply will be higher. It has to be a price you're willing to pay. Yeah, I think that's good for privacy enhancing tech. All right, next up. So Databricks actually has secured images, hardened images that are supposed to be harder to attack. So, these are level 1 VM images. The encryption is validated. So your data is encrypted at rest and in motion when moving through these types of VMs. They do qualify for PCI, HIPAA, DSS, FedRAMP, security best practices. So these images are regularly monitored for file integrity, antivirus, and known vulnerabilities. So that's just baked into the images. Like every image, you're still going to have access to your usage logs. That's going to be the same for hardened or not. So what do you have to do to use these images? Well, first of all, your Databricks account must be an enterprise, or I'm sorry, your workspace must be an enterprise workspace in order to turn on this feature. And it's as little as checking a box and choosing which hardened image you want and what kind of VM size you want. It's very simple. The downside, there are additional costs. So if you're in AWS, you're talking about a 15% surcharge on top of your Databricks spend. So when you're looking at your DBU usage and you're in AWS, you're considering turning this on, add 15%, and that's what you're looking at to secure all of your workload. If you're in Azure or GCP, it is slightly cheaper. It's only 10%, but still there is a surcharge. Another thing to keep in mind, you don't have a serverless option in SQL Warehouse or in your ML. You've got to turn it on first or have it provisioned at job start. Serverless just isn't going to be an option yet. In order to use it, your environment needs to have SSO. So if you're over in Azure, you've already got this. Azure Active Directory is your single sign-on source. If you're in AWS or GCP, you're going to have something like Ping. There's a handful of SSOs that Databricks works with. Check the docs. It's pretty easy. So the logs that are kept, they do not include alerts, reports, or anything like that. You're still going to have to build those reports. I'm actually going to share some of that in a later slide. The hardened images do take more time to start up. In our testing, we're seeing about a 40% penalty for these hardened images. And think about it. It's loading more than just the base images to these worker nodes. You've got antivirus running. You've got some extra services running that just aren't there in the simple images. So it makes sense that they're going to take longer. To me, I used to be a DBA. This is the one that scares me the most. You're going to actually have reduced stability. So when the image that you've built your workload on top of receives a security update, it's going to reboot on you. You might be in the middle of the job. It's going to reboot on you. It's going to apply the patch, and it's going to get you back up and running as quickly as possible. So just keep in mind, it's a possibility. Some other things we've noticed in testing, you are going to be blocked from using things like /temp. So if you're writing workloads that download a file from the internet, we all put it in temp, then we write it somewhere in either DBFS or we write it to our blob storage. You're not going to be able to do it that way. You're going to have to download it to a named location. In Unity Catalog, we could be talking about a volume here. Write it to a volume, and then come along and read it into wherever you really wanted to put it. Those are the big catches that I've seen. But overall, it does improve your security.
Shannon, I've got a question about the reduced prod stability that you mentioned.
Mm-hmm.
So you mentioned that images may reboot. We don't have any control over that. Can you talk a little bit about how we've approached dealing with that from a product integration perspective? If I've got pipelines running, what are some of the things, some of the ways you've tackled that?
So actually, this was solved back early in our pipeline process. So when we design a pipeline, we allow for steps along the way to fail. So instead of having an entire process be this giant monolith that either passes or fails all in one go, we actually break it down into steps. You've got all your ingest steps running. If any one fails, at some point later in the process, they're going to retry. They're going to try again after so many minutes. When it fails again, it's going to increase. Say first retry is 5 minutes, it didn't work. Seconds 10, seconds a third would be 30. Simple retry policies. The other thing is our pipelines, they keep track of dependencies. So if one of your ingestion pipelines fails, only your transform pipelines in the middle that depend on it can't start. All the others will continue along their way like nothing happened. So, and we repeat that pattern over and over again. So when you have a cluster restart, basically the last job to succeed that's marked, all the ones that were in flight, simply restart. It does require more planning up front of your pipelines to plan for this. But to be honest, that same consideration needs to be made for all data pipelines. It's not just a security thing. We're dealing with the cloud. The cloud isn't, 99.999 still isn't 100. You got to plan for failure. Does that answer your question? I see a grin. I'll take it as a yeah. All right. Finally, I get to do a demo after this one. Yay. So Databricks audit logs, like I mentioned, they're in the secured images and in the plain images. You've got to go into the workspace and enable them. But once you do, everything that happens in Databricks is actually logged to files. You've got a whole bunch of JSON files that get written all the time for all kinds of events. And I'm going to show you those. But Databricks is actually taking a step forward. You don't have to deal with the files. If you're using Unity Catalog, if you look in the system schema or system catalog, you'll find your logs and they're already transformed into Delta format. That means easy querying. But if you're in a situation where you can't use public preview features, you'll have to actually ETL those files into a Delta table to do the demo I'm going to show you shortly. There are third-party tools that are custom built to extract meaningful information for these audit logs, and you can go check those guys out. But you don't have to. With a little time and effort, you can query the information you're looking for out of the query logs. And with that, let's go into my demo. All right. So actually, I want to open up a new window before I go into the demo. Wait, open a new window. There we go. We're going to go into our workspace settings, and we're going to go to these settings, and you're going to want to turn audit logging on. Once that's on, you're writing the files. You don't have to. Like I said, if you're using Unity Catalog, you don't have to do this. You can go straight to the tables I'm going to show you in a moment. Wait, I just noticed you're not seeing the right screen. Sorry. Let me do that demo again. There we go. Admin settings, workspace settings, audit logging. If you turn that on, you're writing those files. If you turn it off, you're no longer writing those files.
Hey, Shannon.
Yes.
Sorry for interrupting. Did these configuration changes also get written to the files? So I would know when logging was enabled or disabled for some reason.
Yes, you should see it go off, and we can look for that when I show you activity types.
Thank you.
Yeah, so that's a great question. Let's go ahead and recents, check out the audit log. So this is a workspace that's in Unity Catalog. There's the system catalog. There's my information schema. Here's my access schema. And that's the one we're going to dig into today. We're going to look at this audit. So I've already run these queries for you. You can look across here and you'll notice your workspace ID. So if you've got more than one workspace, you can actually pull them all to Unity Catalog. You can actually query across all your workspaces. You don't have to go workspace by workspace by workspace. That's one of the benefits of Unity Catalog. Here's when it happened. Here's a date in case you just want to do it by date instead of date time. Source IP and user agent, that tells you what's being used to run it. These nulls that I'm looking at are actually service jobs. So let's see. Oh, here we go. Here's some external queries, IP, what they were using to connect, the session ID, who it was. Hey, look, it's me. What service I was using, and then the action name. And the next query, I'm going to show you a list of those action names, and we're going to see if logging is one of them or if it's just configuration change. You can also track it by request ID. So each job you submit, each notebook you run, each cell in the notebook you run, that is a request. We can uniquely identify that in the log. And then request parameters, This is the one that changes the most. This is, depending on what activity you're looking for, this JSON is going to be very, very different. So a notebook run has different information than a cell run, is different than a query run, is different than a configuration change. So this one changes the most. Second most is the response. Like the first is what was requested and the second is what happened. So you can query what happened. You can also query what happened as a result. What was the, what happened? You can also see what level the audit was captured at. You do track things that happen at the account level and at the workspace level. So let's take a peek and see. Well, I've got it sorted by action name. I don't see audit log. So I'm going to guess it's just going to be, oh, wait.
I think there was those log file disabled. Actually.
Oh, you saw it?
Yeah, up at the top.
Oh,
Yeah.
log files deleted.
Oh,
so
deleted.
I can actually see when they're getting cleaned up. Yep. Let's see. Cancel, delete, create. I can see when groups are created. I can see when a Git repo is added. I can see when someone creates a notebook, runs it, when they create a pipeline. I can see when they create staging tables or regular tables, when they make visualizations. It's all here. Everything that you do in Databricks, you can find here. It's just asking it the right way. So this is what I mean. I wanted to find out who's running what notebooks, commands in notebooks, or queries that are accessing different tables. I want to know who's accessing what and when. So just the user is a run command. Here's the full request. But let's see. No, sorry, this is just the who's doing what. The next one is, here we go. What table was accessed? In the last 5 days. Running. Here's the notebook pulled out that Tenny was running. And I'm going to guess in your notebook, nowhere did you actually query a Unity catalog table with this one, would be my guess. Here we go. Select current user as user is member. Yeah, that's not a table. Yep. So we're not going to see any tables because no tables were accessed. In the queries that I do, I'm actually selecting from tables, for example, test table or sample PII data. You can change the query and you can filter it by table name and say who accessed this table. You can also filter down to who accessed this column. So since we can see the full command, you can parse that and pull out column names, tables, objects, the whole thing right here.
Hey, Shannon?
Yes.
On that response table there, the response column, is it actually the response or is it a response code? I can't really quite read it.
Most of the time it's response code,
Yeah.
but if it's an error message, you get the full error message. If you get result sets back, you'll actually be able to see the top 100 rows of the result set too.
So if Tenny's query had said, show me the people that bought brown sneakers last month, show me the username, for instance, that could be here.
Yep, you could. This is your basic query. You can, yeah. Who asked about brown sneakers? Who asked about shoes? Who,
right. Or a medical condition or something you can imagine, like
medical condition.
So yeah. Is there a way to apply our privacy techniques to these tables as well? Can we say no PI in tables, or will that be a roll your own type thing?
Actually, the process I'm trying to build now is I want to take our tag store and our group and actually show who's accessing just our secured columns and do it by tag type. So you could do a version of this, who's accessing PII, who's accessing HIPAA. Then you could take it a step further and you could ensure all those queries are using the appropriate privacy function. So it takes some time to build, but you can build on this concept. It's all in the audit.
Yeah, one of the things we see from the privacy world is how do we make sure that people aren't accessing PI inappropriately? And one of the the vectors, so to speak, is logs. How do I know that engineers aren't kind of groveling through logs and they're looking at this kind of information? And so I think you're describing a defense in depth strategy. Like there's a reason to have the response because you're debugging, for instance, but you need to apply proper security protocols on top of that to know who's accessing that data, much like the actual the original table.
Yeah. So yeah, you could absolutely, you'd get a small snapshot right here of the data set. It won't be the full, but it's enough that maybe it hits the information that you're trying to pull.
So we could create a workflow that's kind of like monitoring who's looking at the logs, which are monitoring what people are doing.
Yes, it gets very meta.
Yeah.
We're talking about inception logging at that point.
That's right. Yeah. Cool. And that's that's part of the solutions architecture approach that we take. Is these are some of the considerations we have, that we have to build these tools with these basic functionalities that are available here. Yeah,
that's it.
Cool. Thank you.
Sure, I can share again. I think we've just got the ending slide.
So I just want to kind of put a little bit of perspective on this from the privacy person's point of view. I think all the stuff that Tenny and Shannon showed us are like these really critical tools that we can use. But as we see with all of our clients, and like we just discussed, it's not just a matter of configuring these tools. It's really thinking about, who are the players within your organization who need access? What do they need access to? How do you monitor that access is appropriate? And again, and like we just talked about, even monitoring something like an SRE team or something, we've got to create tools and use tools that make sure that even their internal access for legitimate purposes is still complying with our rules, because if we're returning PI or PII, we've still got an obligation to make sure that we're kind of locking it down as much as possible. And I think that's where Blueprint's approach comes, where we're not just here's some technology and use it. We have, you start with data governance. What are the rules? We do this privacy engineering and data engineering so that we architect these systems. We try to future-proof them. We try to consider all of these considerations, all of your use cases, from engineering to data science to customer service to marketing to sharing with outside parties for like service providers, that kind of thing. And then we have that, that compliance, kind of what's really happening and being able to demonstrate when we say we're complying with the privacy law or we're doing GDPR or something. These are some of the core tools that we can use to actually demonstrate that compliance, which is kind of its own function to kind of make sure who will guard the guards. So thanks so much for Tenny and Shannon for putting these pretty detailed demos together. Very interesting.
Awesome. Thanks so much, team. I'm just going to give it a couple seconds to see if anyone has questions in the audience that you'd like to add in. Feel free to add them to the comments. But while that's going on, I just want to let you know that we do have an awesome lineup of more of these webinars, workshops, and demos coming up. So if you are interested in joining any of them, just hop over to our LinkedIn page. Everything's listed out on the events there. It's also on our website at bpcs.com/events. You can register for all of our LinkedIn Live events, and super easy. All you have to do is just click attend on that event, and you will be notified when the event is going to be taking place. But a big thank you to, like Kevin said, Tenny, Shannon, and Kevin for putting all of this together. It's great information, and we hope to see you all on our next webinar. But thank you so much for joining, and we hope you guys have a great rest of your day.